but it's enough to help. Let's say that. Okay.
I'm going to a swimming, so I can get.
All right, here we go.
I am.
Number
I
13,
live
practice
with
test
two
2, number 13A. Practice test 2, number 13A.
Yeah.
We have a squirrel in the top of the tree.
I'll see you gotta go.
And the squirrel is looking at a nut on the ground that is 52 feet away from him. So the nut is 52 feet away from the squirrel. The angle is 17.7 degrees on the height of the tree. Picture look okay? So
Yep.
now you look at the sides that are marked. The sides that are marked are opposite, there's your angle, so opposite and hypotenuse, which means you will use sine. So sine 17.7 equals x over 52. X equals 52 sine 17.7. Do make sure your calculator is set in degrees. I am not, so I'm going to give you a check. And type 52 sine 17.7. And it looks like the tree is 15.81 feet tall.
Yep.
Okay? A fish in the water. 100 feet from shore. So here's shore, here's the fish. Spots a seagull on a jetty. Here's the seagull up on the jetty. It's 12 feet high. What is the fish's angle of elevation? Remember, our angle is always here. Whether it's elevation or depression, we're going to put our angle here all the time. So again, we look at the marked sides. This side is opposite, this side is adjacent, so we will use tangent. So tan x, tan x equals 12 over 100, opposite over adjacent. What special thing do we have to do when x is the angle? Inverse. So x is going to be inverse tangent, 12 over 100. So second tangent, 12 divided by 100, 6.84 degrees. One more time. On this problem, I used my regular sine button. On this problem, I used my second tangent button. What's the difference? I use this button only when I'm finding degrees, when x is my unknown. All right, an airplane is approaching an airport. Find the desired angle, and I always put my angle there. If the pilot wants to land at a point that is currently 7,000 feet from the plane, so he wants to land right here, 7,000 feet from the plane, and the plane is 235 feet above the ground. You need to be able to draw that picture. So do those numbers make sense to you? All right, look at the marked sides. What's marked? This is opposite and hypotenuse. So that's going to be sine. So sine x, oh, here we go again. Sine x equals 235 over 7,000. So I just do inverse sine. Second sine. When x is your angle, you don't do any math at all. You just go straight to the calculator. Second sine,
1 point.
and got 1.92 degrees. 1.92 degrees. All right. D. Find the height of a flagpole. It makes a shadow. Find the height of the flagpole. That makes a shadow 16.62 feet long when the angle is 64 degrees.
Opposite over adjacent.
I got opposite and adjacent, so therefore my equation will be tangent. So tangent 64 equals x over 16.62. Am I going to use this button this time? No way, no say. We're going to multiply by 16.62. Type it in. And I got 34.08
Yep.
feet. How high is the flagpole? 34.08. Your test will only have 3 word problems, not 4, not 5. This is just extra practice. What is the angle of elevation of a man looking at the top of the building? It's 48 feet tall. If he is standing 300 feet from the top of the building, or 3,000 feet. Where does the 3,000 go?
On the hypotenuse.
On the hypotenuse. Here's the man, here's the top. He's standing 3,000 feet from the top of the building. Sine, cosine, or tangent? Sine. Sine x
Inverse
equals 48 over 3,000. Do not multiply by 3,000. Don't do anything except type in
inverse.
second tangent, inverse tangent, 48 over 3,000. Second tangent, 48 divided by 3,000. Bless you. Wow, did you get 0.92?
Yep.
So it's a tiny little angle, 0.92 degrees.
You have to label
Tiny little angle.
the bottom. Like where you wrote, oh, like that one plane.
No, you don't have to label it, no. Now, you do have to draw a picture, because you'll get a point for the picture. But how you label it, that's
I
it.
think that's all anybody.
Okay? All right, here we go. Number 1, change into degrees. What do we do? This is no calculator now, although you'll have a baby. I'll have a little one to help you. What do we do here? Change into degrees. 2 times 180 divided by 5, so is that 72?
Yep. Agreed.
Now, how do we change into radians? That's a little harder. What do we have to do to change into radians? Pi over 180 equals x over 100. So 180x equals 100 pi, cross multiply, and then divide by 180. So x equals 5 pi over 9. Now we have our arc length problem. All right, so this is kind of the picture you're going to want to draw. Although you don't need to draw a picture, what do you need to remember? What do you need to remember if it's an arc length problem? that plus. Arc equals radius times radians. So you don't have to have a picture, but you do want to have that formula. So your answer, you're finding the arc, you're finding this right here. That's just going to be two things times each other. And the two things are going to be the radius, which is 6, and the radian measure of the angle, which you don't know. What do you know about that angle? It's 125 degrees. So what are we going to do? Exactly what you just did. We're going to change 125 into radians. So pi over 180 equals x over 125. 180x equals 125 pi. Now, normally, like this one here, we can cross out zeros. Here you can't cross out zeros, but you can reduce that because both of those are divisible by 5. So that 5 into that is going to be a 25 pi over 36.
Yep.
And that is what goes here. And then you're ready to multiply. So I have 6 over 1 times 25 pi over 36. You can go straight across, or might be easier to cross cancel. And the answer is 25 pi over 6 centimeters. If you went straight across, you'd have 150 pi over 36, and you would need to reduce that. Radius times radians. This is the third time we've done this. Have we had to do this every time we've done this problem? Yes, it's going to be a 2-part problem. Your angle is going to be given to you in degrees. You're going to have to change it into radians and then multiply. All right, find all the stuff. So we need to find sine, cosine, tangent, cosecant, secant. And we are told that the cosine is 2/3. Which, by the way, means the secant is 3/2. Boy, don't miss those points, that's easy. Now you need a picture. And what we have to figure out is, where do I draw my picture? The good news is they tell us. Where do they tell us to draw the picture? In the problem, they tell us to draw the picture where? In between 270 and 360, right? That's right here. So I'm going to draw my butterfly bow tie. The cosine adjacent over hypotenuse is 2/3. We've done this a lot. What has to happen next? Pythagorean theorem. So go ahead and do your Pythagorean theorem. Tell me what you come up with. Square root of 5. That's exactly right. Be careful though, that square root of 5 is actually going to be negative. Remember, if you are not in quadrant 1, mark something negative, okay? Ty, where's your lanyard? Kendall, where's your lanyard? Most of us. Good? so I can fill in everything else. What's my sign? Here's my angle right here. What's my sign? Negative root 5 over 3. Tangent is negative root 5 over 2. Everybody okay? And then we'll flip them. So the cosecant is 3 over root 5. Negative 3 root 5 over 5. Cotangent is 2 over root 5. 5. Lots of points there because there's lots of answers. Everybody okay?
Yep.
All right, next one. Check out the notation. We just did some word problems where we used that notation. That notation means we are looking to find an angle, right?
Yep.
So when it says this, my answer is going to be some degrees. I need to figure out how many degrees. So I'm going to draw a picture in quadrant 1, because with this kind of a problem, that notation, a positive number always means quadrant 1. Okay? Tangent, opposite over adjacent, 1 over 1. Makes the hypotenuse then root 2. And you should recognize that. How big is that angle? 45 degrees. The answer is 45. It's that easy. Here's another one. Same thing. Only this time the angle is negative, which means you're not drawing it in quadrant 1. It's going in 2 because it's a cosine and it's negative. So we're drawing it in quadrant 2. Adjacent hypotenuse. That side would be a 1. And that angle is how big? 30. Now, you told me the angle is in quadrant 2, and you were right, it's in quadrant 2. But if you're in quadrant 2, you're automatically between 90 and 180. 30 is not between 90 and 180. This is your angle. That's your answer.
150.
That's 150 degrees. So the answer to the question is 150. 30 is the right, beginning point, but I have to be in quadrant 2. 150, 180 minus 30. All right, you doing okay? All right, we'll finish this page real quick here. What do you think? Tangent 3 pi over 2. What do I need to do first? 3 times 180 divided by 2. So that's going to be 270. 270 is not the answer. 270 is the angle that I'm going to draw. Oops, it's right here, isn't it? So what do I do since it's on the axis? I'll make a circle. The radius is 1, which means that, here's the origin, straight down 1. What will be that point right there if I come straight down 1? 0, negative 1. So x is 0, y is negative 1. And I want tangent. That's on my sheet if I don't have it memorized. Tangent is y over x. So y over x will be negative 1 over 0, which is undefined. Y over x, tangent, y over x. Isn't that the same thing? 5 pi over 6. Anybody know what 5 pi over 6 is?
150.
150 is gonna be over here. Right?
Yep.
Butterfly bow tie it. Now, here's the key, that angle right there, it's 150 and 180. So that is 30.
One.
So 1, root 3, 2, and the root 3 is negative. You want sine. Sine is opposite over hypotenuse, so the answer to that problem is just 1/2. Alright, a couple more of those. Alright, 7 pi over 4. Anybody got that figured out yet? 7 pi. You'll have a little calculator to help you with that arithmetic. 7 pi over 4 is 315. On your homework, some of you wrote down 315 as the answer to the question. It is not. The answer to the question is the cosine of 315. So we need to draw 315, which will be down here in quadrant 4. Right? And then we gotta find this angle, which is the angle between 315 and 360. So that's gonna be 45. And the sides of a 45 are 1 root 2. That would be negative. And I want cosine. Cosine is adjacent over hypotenuse.
Yep.
Root 2 over 2 is your final answer. 1 over root 2, which is root 2 over 2. One more of those. Cosecant, 7 pi over 6.
210.
210. So again, draw on 210. Down here. 3. Perpendicular. 180 to 210. 180 to 210. 30. 1 root 3, 2. And both of those are negative this time. Right?
Yep.
Cosecant. This is going to be on your cheat sheet. Cosecant, I should call it a reference sheet. Cosecant is hypotenuse over opposite. So hypotenuse over opposite is 2 over -1 or -2.
I don't need that.
Number 6. This is kind of a tricky one. It says secant is negative and tangent is also negative. So you want secant and tangent to both be negative. I don't know which quadrant it is, but it is not 1. Would you agree with that?
Right.
You can't have negatives in 1, so don't even try that one. Alright? So let's try one. Pick one. What do you want to try? Quadrant 3. Let's try quadrant 3. Now, in quadrant 3, negative, negative, positive. Would everyone agree with that? Right? Hypotenuse is always positive. Now, what is secant?
Hypotenuse.
Secant is hypotenuse over adjacent. So that would be positive over negative. Does that work out to be negative?
Yeah.
Yep, that's a winner. That's a winner. All right, what's tangent? Opposite over adjacent. Uh-oh.
No.
Opposite over adjacent will be negative over negative, which is positive, and I need it to be negative. All right, so it's not there. We tried it, it didn't work, it's not there.
Quadrant 4.
All right, which one?
4.
4. So in quadrant 4, you have positive, negative, positive. Right, positive, down, negative, hypotenuse, positive. Okay, what's secant? Hypotenuse, uh-oh. Wouldn't hypotenuse over adjacent be positive? And I need it to be negative. Guess what quadrant we're in? 2. 1, 3, and 4 didn't work, so it must be 2. By process of elimination.
Already voted.
All right, now we have our sketches. You know what a sign looks like? Oh Lord, I hope so. This is a regular sign, so it looks like that. Remember, you get half credit for that. Now let's put some labels in. What's the top and the bottom gonna be? 2 and negative 2. I need 1, 2, 3, 4 labels. And I know they're normally 90, 180, 270, 360. What's happening?
They're being
I'm
divided.
dividing by a third, all of them, which is timesing by 3. So 270, 540,
810,
810,
1080.
1080. You'll have a little calculator to help you, so don't think. What's my period? 1080. What's my amplitude? Got it. Good job. Anybody, we did that pretty quickly. Anybody have a question about that? Tan 2x.
2x.
So, first of all, you need to know what a tangent looks like. So tangent has asymptote, squiggle up through the origin. There's my tangent. Are there any labels on the vertical axis? No. Even if there's a number out here, it doesn't matter. There's no labels on the vertical axis because the amplitude does not exist. These should be negative 90 and 90. But we are dividing, remember this number always divides. So we're dividing by 2. So my actual labels are negative 45 to 45, which means my period is 90 degrees. We getting that, folks? You gonna be okay with that? And one more. And this one has a negative in front of it, so we know that means what? It's gonna be upside down. So normally, my cosine curve is gonna look like that. Starts at the top. This one's gonna start at the bottom. It's gonna make a hill and finish at the bottom. That's what it does. It ends the same place it starts. So if it starts at the bottom, it's gonna end at the bottom. How high does it go? 1/2. So your amplitude is 1/2. Notice it's positive. Amplitude, period are positive numbers. These labels should be 91, 82, 73, 60. But what's happening to them? They are being divided by 2.
45.
So 45, 90, 135, and 180. So my period is 180. Got it? Are we okay? We good with that? All right, let's get our big calculators out then. And let's convert to degrees, minutes, and seconds. Make sure that you write down what the calculator says. Don't make stuff up. So 128.735 second angle DMS 128.44.6.
Yep.
Kids, that is so easy. Don't miss that.
Yes, ma'am.
Now, this next section is the section I cautioned you about before.
1 divided by.
Some of these are going to have to be done in radians. Which ones are going to be in radians? Which problems are radians here? B and C and E. How do we know those are in radians? They don't have a degree mark, right? If you got a degree mark, you're a degree. Otherwise, you're a radian. So let's go through and do all the degree problems. Since my calculator's in degrees, we'll go ahead and do all the degree problems. Cotangent, 311. How do I type in cotangent? 1 divided by tangent, 311. Negative 0.8693. D is another degree, D. So sine 52 second angle degree, 11 second angle minute, 12, oops, I just did second, I need alpha plus 0.7900. And tangent, 153 second angle degree, 17 second angle minute. Negative, which one is this? F, negative 0.5033. Are we okay with that? Now, what do we do to do the other 3 problems? We go to mode and change our calculator into radians. And then we'll go back to B, second sine, 0.514. Did you get 0.5398 for problem B? Tangent, 18 second pi, use your pi button, divided by 17.1869. And cosine 1.3, 0.2675.
Where's my pi button?
Alright. Next problem. See that thing right there, guys? how should my calculator be set? Degrees. So I'm gonna change it right now. Your calculator needs to be in radians for some of these, and that's it. Other than that, you need to be in degrees. So once you change to radians, make sure you change back to degrees. All right, sine, cosine, or tangent. This is like a word problem, but it's not a word problem, but it looks like it. Here's the tree, there's a squirrel, there's the nut. Okay, how do I set this up? Sine 37 equals x over 12. So x equals 12 sine 37. And that's it. So 12 sine 37, 7.22. Yeah. Now, this one is a little bit more challenging because the triangle is oriented differently. We don't see squirrels and things with pictures that look like this. But the rules are the rules. There's your angle. So which side is this? Opposite. Which side is this? Hypotenuse. Which function are you going to use? Sine. So sine x equals 18 over 19. And inverse sine. And that's it. That is it. So second sine 18 divided by 19. 71.33 degrees. I need a course of 204. All right, who can tell me what I have to remember to do this problem? It's very easy, but I have to remember something. I have to remember how to label the directions. How do I label the directions? 0 at up top. 0, 180, 90, and 270. So a course of 204 would be down here. Done. Another super simple problem, but you have to remember that's how you label your compass. All right, and then this is our problem that we get to do twice. We get to do it exactly, and that means by hand. And then we get to do it with the calculator, decimal, and that means with the calculator. So let's do that one first. Because, do you have all of these buttons on your calculator? So you just type it. So we just type tangent, second cosine, 2 divided by 5. And we get 2.2913. Everybody got? Just type it in. Nothing tricky. You don't even need to put in parentheses. They can pop up automatically. Now, how do I do it by hand? Well, I draw a picture. Inverse notation. I start in the parentheses. I'm drawing the parentheses. Inverse notation, positive number. Quadrant 1. Adjacent is 2, hypotenuse is 5. what do I need to do to finish my picture? Pythagorean theorem. So go ahead and do the Pythagorean theorem and tell me what you get.
Root 21.
Square root of
21.
21. A squared plus B squared equals C squared. Now that is a picture of my parentheses. I want to look at that picture and find the tangent. For that picture, what is the tangent? Opposite over adjacent. Root 21 over 2. And if you want to check that, and you do the square root of 21 divided by 2, you should get exactly the same answer. All right, here we go. Let's see if we have 9 minutes. Can we get these 5 problems done? Let's see. Squirrel on the top of a tree. 64.5 feet tall. Looking at a nut on the ground, of course. Angle is 27 degrees. Find the distance from the squirrel to the nut. Hypotenuse, squirrel to nut. Miles?
So it ain't say from the square, from like the nut to the bottom of the tree?
Yep. Yep, the distance, if it said find the distance from the nut to the tree, that would be this distance right here. Yep. All right, sine, cosine, or tangent? Sine. If you are still in mystery land, you can't figure out how do you know that sine. Remember, this is opposite and hypotenuse. That's sine. So we'll multiply by x and divide. So 64.5 over sine 27. I'll let you type that in if you want to. That's the setup. All right, let's get B. We got a pelican on the top of a White House. And he's looking at a crab in the water. The pelican is 93 feet above the sea, and the pelican is 202 feet from the crab. Does that picture look okay? And I want to find the angle. Sine, cosine, or tangent? Sine. So sine x. Remember, it's always sine angle. The angle always goes with the sine. So sine x equals 93 over 202. What am I going to type into my calculator this time? Inverse sine, 93 over 202. Airplane. $4,500 feet above the ground. Angle of depression 16.3. How far is the airport from the point on the ground directly beneath the plane? Here is the point on the ground. How far is the airport from the point? That's x, right?
Yep.
Okay? Sine, cosine, or tangent? Tangent. Tan 16.3 equals 4,500 over x. Multiply by x. And divide. So 4,500 over tan 16.3. have a question about that?
Two.
Got a flagpole. Find the length of the shadow, shadows are on the ground, of a 19-foot flagpole when the angle is 59. Sine, cosine, tangent. Tangent. So tan 59 equals 19 over x. We'll multiply by x and divide. Last one. I got a Precal student looking at the top of a building. What is the angle? The building is 51 feet tall, and the kid is standing 200 feet from the building. Where's the 200 going? Right here. What's that? That's the distance to the top of the building? Not what it said, from the building. Okay, sine, cosine, or tangent. So tan x equals 51 over 200. Inverse tangent, 51 over 200. Legend. Your test won't have, I think I already told you, it won't have 5 of those. I only have 3. Three problems. Probably have a squirrel, or a lighthouse, or a building, or a shadow.
Oh, okay. Just let us know all of it.
Alright, and then you are gonna let me know after school day and send me an email if you would like to help with the auction on